Alright, how's it going, 7th graders? Today I'm going to be coming at you with lesson 1 of chapter 2, and this is all about minerals. So if you could, as you're watching this, one thing that's going to probably help, because there's a lot of information, is to open up your book. And if you can follow along with me as we go through, it'll be nice and easy. So go to page 32. The first thing is, how is a mineral identified? The key question is the first one you'll see, and then here's the key answer. A mineral is a naturally occurring solid that can be formed by inorganic processes and has a crystal structure and a definite chemical composition. So we're going to look at the next page on 33. And we said there's 5 boxes. The first one says naturally occurring. Naturally occurring inorganic processes. It's a solid and a definite chemical composition, abbreviate. It has a crystal structure. So these are the 5 things. So the first one, naturally occurring. The examples it gives in this thing's going nuts on me today. Stop. The first thing it talks about is coal versus quartz. So naturally occurring. When they mean that it's naturally occurring, it's something that can just happen in the open environment and it doesn't need any assistance. Now, what the quartz is, that happens it's formed from slow cooling magma. So slow cooling magma is going to do the quartz. And for the coal, it's actually just intense pressure. It's intense pressure from dead trees, stuff like that. Trees, plants, ancient trees and plants. That's where coal's coming from. So they both fit. Coal and quartz are both going to fit in the naturally occurring process. Now, inorganic processes. Now, because magma is inorganic, it's just melted rock, that fits it. It checks off for it. But when we're looking at the pressure built up on trees forming coal, you can see that there is organic in it. Now, inorganic means not living, never was living, never will be living. But inorganic means, that's inorganic. But organic means that even though it's dead now, it's not living right now, it at one point was alive from being that tree. So actually, you can't check coal off of that inorganic process. The next one is solid. When you look at solid, obviously, both quartz, when you're looking at page 33, and coal are both solid object. They're not liquid, they're not gas. Chemical composition. Now, because it's made by these various trees, various plants, the chemical composition on coal is different. It just depends really what made it. So there is no definite chemical composition, whereas with quartz, there actually is. So check off 1 for quartz, don't check off 1 for coal. And the next one is crystal structure. Coal can have crystal structure, but not in the same way that quartz can. Quartz has a very definite crystal structure, whereas, again, because the pressure of these different plants, they're all different, different pressures, it's not the same. So you can check off 1 again for quartz, but not for coal. So we can conclude that quartz is actually a mineral because it fits in all these 5 categories, whereas coal really isn't. And so these are 5 things that you should always be checking to find out, is this actually a mineral? Oh, this is being a pain in my butt today. There we go. Finally. Alright, so the next thing is, we turn to page 34. And minerals, compounds, and elements. And it talks about, this one you probably want to just do a little bit of reading yourself. And it talks about how minerals are made up of the compounds and the elements. You have your individual elements. Your elements come together. So let's look at this. You have your individual elements. They come together. They create a compound. Your compound, you get a lot of it, and that's just going to form your mineral. So that's the skinny of it, but there's more to it, so read that section. The next thing, how are minerals identified? Now, some of you might have had before fool's gold. You might be familiar with what fool's gold is. Now, fool's gold actually looks like gold, has the same color, kind of the same texture. And so a lot of times you can say, oh, look, your friend might come up to you and say, hey, give me $20 and I'll give you this gold right here. You can be rich. Well, you can use all these different steps to try and identify if fool's gold is actually real gold or if it is something else. So there's three things that we have listed on page 35. We have color, we have streak, and we have luster. There it goes. It's a little bit delayed. So let's do this one first. Color. Fool's gold. What color is it? Well, it's gold. And so it looks like gold. So that test really isn't going to help us. But in other places, you can hold up, this fool's gold and say, hey, look, it's a diamond. You go, it's actually the wrong color, so no. Now, the thing to be careful with color is because obviously with fool's gold and gold, it shows that very few minerals will actually have their very own unique color. A lot of them share it. Now, let's look at luster. The luster would be about the same. You can use different words to describe it. You can use metallic, silky, waxy, greasy, or pearly. Use those words. Don't use, I was asking in class, what would you use to describe silver? Someone's like, silvery. Like, no, don't say silvery. Use a word like metallic. Look at it, feel it. What does it look and feel like using one of those words? The metallic, silky, waxy, greasy, or pearly. Look at that book and look at those bottom ones. You have galena, macalchite, and talc. Oh my gosh, I probably butchered that. Don't make fun of me too much. But you can see that that's how they pick up their names. Now the last one is streak, and this is where fool's gold, if you ever have somebody trying to, play it off as, oh, this is real gold. When you have fool's gold and you streak it, so you just take it and you rub against like a white piece of paper, it's going to be about a greenish black. Now the cool thing is all minerals, even if one's like a little bit dirtier, so you might have gold that's maybe a little bit darker than other types of gold, just because they're on the other minerals that's been around or where it's found. But the streak will always be the same color as long as it's the same kind of mineral. But with stuff like fool's gold, even though it is gold, its streak is actually that greenish black. So sometimes the streak is actually different from what the actual color of the mineral is. So that's kind of cool. So that's how scientists use that stuff to identify minerals. Now, there's another thing that they use is hardness. And they bring up Mohs hardness scale. This is a simple 1 through 10 scale. So you have 1, 2, 3, 4, 5, etc. Until you get to 10. And where a mineral fits. Now up here you have diamonds, which are the hardest. They fit under 10. Now over here on 1, you'll get something like talc, which is soft and you can actually scratch with your fingernail. And the way that they assign them, so they might have like quartz on here. So if you're looking at your book and you have already solved the problem, like number 7 is quartz, number 8 is topaz, and number 6 is feldspar, what they're saying is quartz can scratch feldspar, but quartz can't scratch topaz. Topaz can scratch quartz though, and feldspar can't actually scratch either of them, but it can scratch any of the ones below it. So if it's below you, that means you can scratch it. If it's above you, that means you can get scratched by it, but you can't scratch it yourself. And so that's Mohs hardness scale. Alright, next one you have density. Density, really simple thing, is all it is. To understand what the density of something is simply mass over volume. To find out the mass, you just weigh it. To find out the volume, you put it in water. The reason you put it in water is because as you put something in water, it'll displace the other water. So think of like a full bathtub. Say you fill up your bathtub right to the brim and you sit into it. What's going to happen? Well, the water's going to spill over, right? Well, that's because you take up a certain amount of volume. The same thing is they'll do that with the rock. They'll weigh it first, they'll check the volume, then they do mass divided by volume equals that object's density. And actually, minerals have a specific density. There's that story of Archimedes that I shared with you guys and how he wanted to figure out, was the crown made of entirely of gold? Now, he was able to figure out that it wasn't made entirely of gold because there was something else in there that was a different density, and it took up a different amount of volume. And so that's how he was able to figure it out, and that guy ended up getting killed. So, won't cheat kings. I guess that's the story behind it. Now, the next thing that makes minerals unique is they all have their own. Oh my goodness, it's going crazy today. They all have their own crystal structure. How the minerals form together is actually very unique for each one. And the cool thing is you can take, say you take one of those laser point pens, shoots a laser beam, a little dot. When you shoot it into different minerals, the crystals will actually show a different arrangement of light. So if you have the halite sitting next to the quartz, if you were to shine that laser pointer into them, you're looking on page 38, you're going to see that the light is going to bounce off and reflect in different ways than it does here and here. Now another thing, these are two words we're dealing with, is you have cleavage and you have fracture. Where'd my pen go? Yeah, sorry, this thing's just going absolutely insane today. So you have cleavage and fracture. So you have cleavage, which, simply put, it's a nice clean cut. It can be split along a really nice edge. You look at that mica and how it can be cleaved apart. And it's all about how the atoms form. Now you have other ones that will do this, called fracture. And that's because how the atoms form is they don't, oh my goodness, they don't allow for a clean cut. And so instead it breaks. It's an ugly cut. It's a very ugly cut. And that's what a fracture is. So cleavage and fracture aren't very hard things to figure out. It's just either cleavage, a clean cut, or fracture, a very broken and messed up one. So let's hopefully this thing will survive so I can get through the rest of this. Now the next question is, how do minerals form? And we're looking at page 40. We're wondering, how are they forming? Well, they can form from one of three ways. They can form as organic minerals, and that simply means animals make them. Think about a pearl. A pearl is formed by a clam in order to deal with if it ever gets any sand inside of its opening, and it forms a nice waxy pearl around it in order so the sand doesn't irritate the inside of the mouth. You also have certain animals that, like corals, that'll produce shells and skeletons made out of calcite, and that's what they live inside of. They make homes for themselves with minerals. So that's how you make organic minerals. Now you can get other ones, minerals from solutions, and that's like if you've ever seen a geode. What it is you have, so you have a rock and it's got all space inside, so you have all these cracks inside. Well, water can get in, and the water brings stuff with it because the water serves as a solution. So to have a solution, you need water, and you need something else, whether it be salt, sugar, dirt. You create a solution. So you put that something else in the water, it dissolves. Oh my gosh, this thing's going insane. It dissolves, and as it goes in, as the solution goes into the cracks of the rock, it can actually form minerals and these really pretty crystal structures. And if you look on page 41, you can see a gypsum rose and some silver and how they're formed through that. And the last one is you get minerals from magma and lava. And pretty much what's happening here, as the magma cools, so you have your volcano that erupts, and as the lava cools, you can either have it cool on the surface, which it's going to cool very fast because it's out in the open air, or the magma that doesn't make it up top, and oh, there it goes. This thing just drives me insane. As it cools underground, is actually this will actually form a different kind because it's actually going to cool slowly. Because it's under the ground, it's not exposed to the open air. And so these are the two different ways that you can form minerals from there. So that should catch you up to where we were at least in the class so far. So if you have any questions, again, feel free to email me at bmiles@somersetnov.org, and I will fill you in with anything you're wondering about. But, oh my goodness, this thing's driving me insane. But until then, you guys take care, have a great weekend, and I will talk to you later. All right, bye.